In this video, we're going to talk about the Taylor and Maclaurin expansion series. Now, this is a formula you got to remember, okay? There's no beating around the bush here of getting around with it. This is a general formula you got to remember. Okay, we're going to talk about what this means, okay? Now, what's the difference between the Taylor series and the Maclaurin series? Well, actually, there is a bit of difference. There's really not much. They're essentially the same thing. The only difference is that the Maclaurin series, we're evaluating the function at x is equal to 0. Okay, and so that is implied. So on a test, if you're given a function, they're not going to tell you that evaluate this function at x is equal to 0. They're going to say, okay, find the Maclaurin series, and so immediately you should know that I'm going to extend the function at x is equal to 0. Now for the Taylor series, it's a little bit different. Okay, we're not dealing with 0 anymore. We're dealing with some numbers. So it could be x is equal to 2 or x is equal to 1. So they have to tell you that. So that's the difference. Essentially, they're the same thing. And so what if we wanted to find the Maclaurin series of the function f of x is equal to e to the x? Remember we said that, and as soon as we see Maclaurin, we should be thinking of the function at x is equal to 0. Okay, and so what I usually do is that I create a table. Okay, and on one side I have my derivatives, on one side I have the evaluation. So f of x in this case happens to be e to the x. Okay, f of 0, well, if I plug in 0 into e, anything raised to 0 power is 1. Okay, now what's my derivative? F prime of x. Well, derivative of e to the x is just e to the x. And so f prime of 0 happens also to be 1. Okay, and I'm plugging in 0 in for x. Okay, now what's the second derivative of e to the x? That also happens to be e to the x. So f double prime of 0 happens also to be 1. What's the third derivative of e to the x? That also happens to be e to the x. And so f triple prime of 0 happens also to be 1. Okay, so you can see that we're just staying constant. So the idea is that we're going to take this and plug it into this formula here. Okay, and so if we're looking at this, we know the function f of x, which is e to the x, expanded at x is equal to 0, could be written as f of a. Now a is the numbers, so f of a in this case is 1. Okay, so this is 1 plus, well, what is f prime of a? That also happens to be 1. So this is f prime of a, what also happens to be 1, times x minus a. Well, what is our a? Our a is 0. Okay, so x minus 0, which is a, and we're going to divide this by 1 factorial, which also happens to be 1. And we're going to simply add it to f double prime of a, which happens to be 1. Okay, we're going to multiply that by x minus, well, what is a? A happens to be 0. Okay, a is 0. And we square that term. Okay, and we divide 1 by 2 factorial. Okay, and then f triple prime, we know that also happens to be 1. We're going to divide that by 3 factorial. Okay, so f triple prime divided by 3 factorial times x minus a, which happens to be 0 cubed. And it goes on, and we could go on and on and on. Okay, and so to simplify this a little bit more, we could say this is 1 plus, well, 1 factorial is 1, so this is 1 plus x plus 1 over 2 factorial x squared. Okay, plus 1 over 3 factorial x cubed. And we could go on and on and on and on and on and on and on. Okay, so what does look, so writing the series as a sum representation, well, this looks like to me is that we have some sort of sum where n is equal to 0 to positive infinity. Okay, well, notice I have x to the n here. So I have x to the n. My first term is 1, so I don't need to, my first term is 1, so I don't need to write 1. So this is x to the n, and I see an n factorial here. Okay, so this series of sum representation comes down to this. Okay, so that's the idea of the Maclaurin series. Now let's do a Taylor series for this same function here. So let's do the Taylor series of e to the x at x is equal to 1. Okay. Well, again, f of x happens to be e to the x. F of 1, okay, f of 1, because you're going to plug in a now, because your a is 1. Okay. So f of 1 happens to be, well, e to the 1 is just e. So e to the 1 is just e. F prime of x, the derivative of e to the x, is just e to the x. F prime of 1, again, happens to be e. Okay, again, because e to the 1 is just e. F double prime of x, again, same thing, e to the x. F double prime of 1 happens to be e. And so you can see if I go to the third derivative, let's do it. F triple prime of x happens to be e to the x. F triple prime of 1 happens to be e. Okay, so you can see that this is going on and on and on and on and on. And so let's use the formula that we know. And the formula says that okay, to expand the function, we're going to say this is f of a plus f prime of a divided by 1 factorial times x minus a plus f double prime of a divided by 2 factorial times x minus a squared, okay, plus f triple prime of a over 3 factorial times x minus a cubed. And again, we could go on and on and on and on and on. Now, some teachers will allow you to stop here. Some teachers actually want you to expand the function at all costs. And so if I'm looking at this, my function f of x can be written as f of a, which happens to be what? E. So f of a is e, plus f prime of a. Well, f prime of a happens to be e also. Okay, so f prime of a happens to be e. And we're going to multiply that, we're going to divide that by 1 factorial. 1 factorial is just 1, so we didn't even need to write that, but I just wanted to show the process. And then we have our x minus, well, what is our a? Our a happens to be 1. Okay. And then we're going to add that to e, which is f double prime of a. We're going to divide that by 2 factorial, x minus a. Well, again, our a is 1, and we square that. Okay. And again, f triple prime of a happens to be e also. We divide that by 3 factorial. Okay. And then we simply multiply by x minus a cubed. And again, it goes on and on and on. Okay. So as a sum representation, what it looks to me is that I have a sum where n is equal to 0 to positive infinity. So I have a sum where n is equal to 0 to positive infinity. Well, what is my first term? My first term is e. But because it's a constant, I could factor it out. So this becomes e outside. What it looks to me is that I have an x minus sum a. So I have x minus 1. I'm sorry about that. Looks to me as if I have an x minus 1, and this is raised to some nth power, and this is divided by some n factorial. So this would be the sum representation of the series.